Hello guys, I am Nidhishri S. Bagalwadi, your science teacher. In the last class, we learned regarding the defects in the vision. We learned three defects: myopia, hypermetropia and presbyopia, as well as we learned regarding the cataract, and also we discussed why we have two eyes. Now we are coming to the straight concept, the main concept of this topic, that is refraction through prism. So in the previous classes, you learned refraction through plane mirror, refraction through spherical mirrors, as well as refraction through lenses. So today we are going to discuss regarding refraction through the prism. First of all, we know the definition of a prism. It is nothing but it is one of the property of light, that is a bending phenomenon of light, is termed as refraction. We know that, right? So here the refraction, when it occurs through several medias, like when the refraction has to occur, there is a condition that the light has to travel in at least two separate mediums. So that we termed denser and rarer medium. So you have to remember the terms like rarer medium, denser medium, incident ray, refracted ray, then where they will bend, and all. These all you have to remember regarding the refraction to learn this concept. So when we come to the prism, prism is nothing but it is a made up of a glass material and which is triangular in shape, 3D triangular in shape. 3D means it is three-dimensional equipment, okay, 3D, and it will be having two triangular surfaces. One is front side and one will be at the behind it. Two triangular surfaces. So prism is made up of two triangular surfaces, okay, and this is one rectangular, this is one rectangular, and here at the base it will be having one rectangle, so one, so totally three rectangular surfaces. So here what we can see, we can say, so here two triangular surfaces and three rectangular surfaces, this is the prism is made up of. Then, so when you see the side view or the lateral view, so this is one triangular surface one, this is second triangular surface, here one rectangle, and this is below one rectangle will be there, and that side one rectangle will be there. And these rectangular surfaces, what I am saying, these will be inclined. Inclined means down, inclined. Both the rectangular surfaces will be inclined. So this is this one and this one. So you can understand, no? So this and this, these both rectangular surfaces will be inclined down towards each other, and they are making an angle here. They are making an angle which is called as angle of prism. Okay, so the light which will always pass through rectangular surface only. So what we can say, the rectangular surfaces are the refracting surfaces, not the triangular surfaces. The rectangular surfaces which are at the sides are the refracting surfaces. So they will allow the light to pass through and they will allow or proceed with refraction. Then what does these triangular surfaces will do? So when a light enters through a rectangular surfaces, the triangular surfaces will not allow the refracted rays to go out. So you can see clearly the refraction inside the prism. Inside the prism you can see the refraction very clearly. So that is the function of the triangular surfaces. So what we should keep it in mind? Refraction always occurs through the inclined two rectangular surfaces of the prism which are inclined and making an angle of prism over here. They make an angle. They two meet at certain point. So that point is called as angle of prism. So the angle between two refracting surfaces or rectangular surfaces is termed as angle of prism. This one. It is designated as capital A. Okay. Uppercase A. Next. So let us consider a prism, and this is a rectangular surface. Okay. And this is other rectangular surface. Both rectangular surfaces are meeting at a point and making angle of prism. Okay. And let us name this as a triangle as ABC for our reference. Don't get confused with this A and with this A. Okay. Okay. Now, let us take a incident ray. So let us take a incident ray PQ, which is incident on the rectangular surface AB of a prism ABC. So here a light ray is entering from the air to the glass medium. So what should occur? The bending phenomena must occur. Okay, the bending phenomena must occur. Just a minute. The bending phenomena must occur. Okay, so here the light ray is traveling from air to the glass. So from rarer medium to denser medium. Glass is a denser medium, we know it, right? Rarer medium to denser medium. So when a light ray travels from rarer to denser, it moves towards the normal, which we learnt in the previous chapter. Okay, so when we consider a normal, let us draw a normal over here. A normal is nothing but a perpendicular to the surface of triangular surface. So this is a normal. Okay, and the angle of incidence, the angle between the normal and the incident ray. So this is an angle of incidence, which is denoted by I. Angle of refraction, the angle between refracted ray and the normal. So this is angle of refraction. Now, a light ray is going towards the air again. This is a refracted ray. Again it undergoes the refraction. So here again we will draw a normal to the surface. Okay. So here what is happening is, let me correct this. Okay. So here a light ray is traveling from denser to rarer medium. So when the light ray is traveling from denser to rarer medium, it bends away from the normal. Sorry. Just a minute. The light ray bends away from the normal. So here PQ is incidence ray, QR is refracted ray here, RS is refracted ray, or we can say it as an emergent ray with respect to this. Okay, so here this is how the refraction takes place through the prism. Next, the angle between this normal and this ray, we can take it as I2, angle of incidence 2, and this we can take it as R2, angle of refraction 2 at the surface AC. This is how refraction takes place through the prism. Okay, so what we learned here, PQ is an incident ray. At AB, okay, at AB. Then QR is a refracted ray, okay. Then RS we can consider as emergent ray. PQ incident ray, QR refracted ray, RS as a emergent ray. Now, suppose if there is no change in the medium or nothing, when you take the incident ray, the ray has to go like this. The actual path of ray should be like this. Okay, so this one. But it got diffracted. Instead of going in this direction, okay, just a minute. I will just show you. Yeah. Instead of going in this direction, it is going in this direction, means it is bending this much. Okay, it is bending this much. Then how much it is bending? How much it is bending? So when you just proceed this refracted ray and this, here you can see D, that is capital D, which gives the angle of deviation, means how much the ray bent. Instead of going like this, it went like this. It went like this. So here when we emergent ray, take the emergent ray and proceed it backwards, not this. So when these two lines meet, so this angle is there, no? So this is called as angle of deviation. Okay. So here angle of deviation means what? The angle between the incident ray. The actual path of incident ray should be like this, but it got refracted. This is the actual path, real path. Okay. Then emergent ray is here. RS is a emergent ray. To get the angle of deviation, what I did, I pulled the RS to this, like, and it met the PQ at certain point. So there where it met, where these two rays met, incident ray and emergent ray, so there a formation of angle takes place which is called as angle of deviation. So this angle, what it gives? This angle gives us how much the light ray is bent, how much the light ray got refracted. So that is the angle of deviation, and very very important, and it is denoted by capital D, capital or a supercase D. This is how the refraction takes place through the prism, and these are the terms: angle of prism, angle of deviation, and these are the rays. The important term here is you have to learn how to draw the diagram. Why? Because you can say, ma'am, it is very easy. Drawing the triangle, drawing three lines, incident ray, refracted ray, emergent ray. No. See, I was wrong here, but I rectified. What I said, I will draw it once again. What I did, when a light ray travels from rarer to denser, it should be seen in your diagram that the refracted ray should be towards the normal. It should be seen, the diagram should say that it is near the normal. And when refracted ray, when it undergoes the refraction from denser to rarer medium, the refracted ray should be away from the normal. That is also should be seen in the diagram. Then only you will get full marks for the diagram. Okay, don't think this diagram as easier one. Practice the diagrams, understand the concept, enjoy the refraction. Okay. In the upcoming sessions, we will learn more about refraction as well as a prism. Until that, have a nice day.